Yeah, comes on everyone. Chal, comes on. Chal. Okay. It will be little weird today. I'm taking class from some other place because I'm shifting my house today. So from morning we are shifting. I said like we can't cancel the class though. Let's start off with a question. Where are others? Right? Why so many people are missing? We have a container filled with liquid. There is a hole here at a distance x from the top. Height of the liquid is h. This is a small hole. And this whole setup is placed on a platform. Let this be 2h and let this be h. So liquid will fall from here and hit somewhere here. This is your range. Find x for maximum range. So we have a container situated at a height of h. The height of the liquid is 2h. You made a hole at an x from the top. It's a small hole. Read the question. Anyone? Answers? Remember, it's a small hole, so velocity will be root 2 gh. It doesn't matter actually what is the area of the container or area of the hole. Is that the range, Aditya? What did you find exactly? The question is find maximum. Okay, find x for maximum range. Yeah, that's right. We have one answer, everyone. Simple one, right? It's just kinematics. So when the liquid is coming out, what is the velocity? Root 2 gx, where x is the height of the liquid. And what is this thing then? So this question has become as if, and this height of this thing is h plus 2h minus x. So when this thing goes and falls somewhere here, the time of flight, I hope you remember, time of flight when you throw it horizontally from a building is root 2h by g, but h ka place mein we have root 3h minus x by g. That's your time of flight. Range is nothing but horizontal velocity into time of flight. So that would be root 2 gx by root 2 3h minus x by g. G will cancel. 2 will come out. You end up with x into 3h minus x. This is your range. You want to find maxima minima. For maxima, dr by dx. So I just need to maximize this function inside. This has to be maximum. Therefore, d by dx of 3hx minus x square ka differential is 3h minus 2x is equal to 0. X is equal to 3h by 2. Got this? So when you make the hole exactly at the center, if you take the total height and if you take it the center, you get a maximum range. 3h by 2. So if you make the hole at a height of 3h by 2 from the top, you get a maximum range. They're kinematics and fluid mechanics. So what is maximum range? You can substitute the value there. So range max will be 2 into 3h by 2. So that is 3h. That's your maximum range. All got this? Clear. Now, if you see this,
सर अभी ये डेटा की वजह से that hole is coming within that 2h का range. Suppose
right,
some other data और वो hole वो
then you take the bottommost point
bottommost point. Okay.
because there's no container only there.
Mm-hmm.
What Utsa is saying is we got x is 3h by 2, so you're taking that grade. But what if x is 5h by 2? That means this should be the hole, na? But there is no container only there. So what is the next best option? The lowest point. So this thing, right, if you take fluid here, if you make a hole at a distance x from the top, or if you make a hole at a distance x from the bottom, you will observe both of them have same range if it is in the ground level. Clear? A simple reason, for the upper guy, the range will be, velocity will be root 2 gx, time of flight will be root 2 h minus x by g. For the bottom one, you'll have less velocity, but you'll have more range, meaning more velocity and less time of flight. Getting this? So you get the same range for two holes if you make a hole from the top or the bottom. And you get maximum range at the center. Again, this is if the container is on the ground. If you keep it on some elevated thing, you don't have an option. You have to integrate, meaning differentiate. Clear with this? Let's see one more. What did I do? I did something. Let's see an easy one. We have a container. Filled with liquid. We have a small circular hole. The moment I use the word small, you can use that root to just thing. Radius A. This is small square hole. Side A. This whole setup is placed on a smooth ground. This hole is at a distance of x. This hole is at a distance of y. Find x by y if the container has zero acceleration initially. Because see, when the liquid is going out, they're like rocket boosters, isn't it? Water jets will exert force. Find x by y if acceleration of the container is zero initially. Get this. That you need to figure out, Adrit. If the hole is small, why should the shape matter? That's a question you need to think. One by pi. Okay, we have one answer. Not sure whether it is right. One. Show you.
सर 2 मिनट
Remember the formula? If the water is coming out with speed v, what is the force due to water jet? Rho a v square. So area will matter, na, what shape it is. Since the acceleration is 0, these two should be equal. Rho, area of the square is v square, and v2 square is 2gy. Rho area is pi a square, and velocity is 2gx. X by y is 1 by pi. Easy? So basically both the holes, right? The speed is root 2gx and root 2gy, but the force is rho a v square, force due to a water jet. So for a square hole, the area is a square, and for the circular thing is pi a square. Got it? How did you get 4, right?
Permanent diameter area.
Okay. Easy, everyone got this? Anika, you got that right. Others? Arjun, clear? Neil? Udian? Clear, na? Palaksh? Next one. Let's see how many of you will do this. So we have a small hole here at the bottom. You place this on a platform. And we have a bucket here. Here, have a look at this fast Aryan. Clear, na? So we have a bucket here at a distance of h by 2. There is a bucket of width h. Height of the container is h. Height of the liquid in the container is also h. And you made a hole here. The area of the container is a cylindrical container. Now see what happens. Initially height is more, so speed will be like this, na? As the height decreases, what will happen? Agreed? So the question is, find the amount of liquid. चला गया आंटी? Find the amount of liquid collected in the container. So how much liquid will fall into the container? Second part, find height of the liquid as function of time t. It's a small hole. Small hole ka area is small a. So just to give you a little thing, this is how the liquid will keep on decreasing its level. Got the diagram? There. Try this. This would be a good paragraph question. Right, Lakshya. The first part does not require any integration and stuff. Get the second part also. Means how they'll ask you, find the ratio of time taken to empty the first half of the tank and the second half of the tank. A part. Aryan God, did you pi h cube कैसा आया God pi h cube? Volume of a cylinder is what? Udian, do keep your cam on. Someone is missing. AY2, Arjun, dimensions are matching. What are you talking? Question is volume. What did you find? Right, Anusha, you got that right. Right, Arjun. Second one, time everyone. The first one is actually a kinematics question. I'll give you an idea. See, at certain height of the water level, you will go and hit this container. Agreed? Find that height. When the water level becomes something like this H2, this water will hit the edge of this container. That means all the water between H1 and H2 is inside the container, na? Is that making sense? When the height is H2, you're hitting the right edge. When the height is H1, you're hitting the left edge. That means all the water between H1 to H2 must be inside the container. Is that making sense? That's it. It's more of a kinematics question for range. Try, I'll give you a minute now. So find H1 and H2 when the water hits the right part of the container and the left edge of the container. Once you know both the heights, question is over. And for the second part, right, I know it is difficult to type. So what do you find is this. Do the C part. So B and C are related. Find a ratio of time to empty first half of the tank, meaning H2 H by 2, and second half H by 2 to 0. If you give me the answer for C, you would have got the B part anyways. But B part ka result is standard result, which you need to mug up actually. Exam you won't have time to sit and derive. Look at the first part. What is that, Anika? Who did you type? You typed something weird totally. See. So when the height is H1, the liquid goes and hits here. That means we are talking range is how much? 3h by 2. This should be equal to velocity v1 into the time of flight, which is root over 2 into h plus h1 by g. Agreed? And what is v1? v1 is nothing but, so this would be 3h by 2. v1 will be root over 2g h minus h1 into root over h plus h1 by g. Gg will cancel square on both the sides. 9h square by 4 is equal to 4 h square minus h1 square. Actually, wait, I'll do something better. Let this be x. So range will be root over 2gx into root over 2h plus x by g. So that will be 2 root over x into h plus x. This is the range as function of the height. So for the first case, so to hit the water at point 1, the range r is 3h by 2. This guy is 2 into x into h plus x star root. Wait. Time of flight is 2h by only, na? My mistake. Because the water is coming from this side only. GG will cancel root over 2xh. So for the first case, range is 3h by 2 is 2 into root over x into h, square it on both the sides. You get x is equal to 9 by 16h. Same thing if you do it for point 2. So that will be somewhere here. Range is h by 2, which is 2 into root over x into h. X will be h by 16. So the volume inside the container will be, so we have two ranges, like all this water between them will be inside the container. Let's call this thing as H1. Let's call this thing as H2. A into H1 minus H2, that would be AH by 2. Half of the water is in the container. Is this making sense? Clear, na, Asha? Did the same? Others, check it out what I did. The time of flight will be root 2h by g only because the hole is at the bottom. I was goofing up that part. All got this. The second part of the question. Find the height of the liquid as function of time t. Get that? You got a minute. If you got the second part, you'll get the third part. And third part is actually a question in the mains. Find the ratio of time taken for the first half and the second half. Velocity be root 2 gx into, it's a small hole record. Given in the question, it's a small hole. It becomes more complex. Or kuch nahi, you're not wrong, but it becomes more complex. See the second part. This thing I always tell you, whenever they ask you something is a function of time t, always start from the intermediate stage. Meaning after time t, let the liquid ka level be x. In time dt, let height decrease by dx. In small time dt, you lost dx amount of height. Therefore, volume that flowed out is area into dx. We'll put a minus sign because the height is decreasing. Same thing, at this point here, the velocity is v. V is equal to root 2 gx. And we know volume rate or volume flow per second is nothing but area into velocity. Remember equation of continuity? A into root 2 gx. Therefore, that's volume outflow should be the volume flowing out per second, A into root 2 gx into small time dt. Agreed? This much liquid is flowing out per second, and if you multiply with time, you will get the liquid flowing out in small time dt. And this would be minus A dx. This is A root 2 gx into dt. Bring all dx's to one side. Minus A by A root 2 g dt. Integrate. When time is 0, height of the liquid is h. This is x. This is t. This will be 1 by root 2x. 2 aega. We get root x. Minus root h is equal to minus A by A root g by 2 into time. You should definitely mug up this result. So root x is equal to root h minus A by A root g by 2 into time. This is a standard result. Sometimes the questions will be more easy. The time taken for the tank to be empty means x becomes 0. Will be time is proportional to root h. So there is a question like this in the exam. We have two water tanks. One height of the water tank is h and another tank is 4h. Find the ratio of time taken for the tank to become empty. So if you have 4 times the height, it will take double the time. Clear? This is the time taken for the tank to be empty. So it is proportional to the height of the root h of the tank. Clear with this equation? Can you do the third part? Find the ratio of time to empty the first half and the second half. So if you want to go from h to h by 2 and h by 2 to 0, find the ratio of the time. There, you need to know this formula to do that. Yeah, it's a mess today. I'm shifting my house and there is some marriage going on. I came to other place, the people are dancing there. Can you hear the music? Chala, good. My headphones are good then. It is worth spending the money on the headphones. At least you guys can't hear. Let's get this. It's a mess. From morning 9 o'clock, we are just packing. Hmm. That was easy. Why are you guys struggling so much? For the first half, you're going from h to h by 2. So basically, x is h by 2. So if you apply the formula there, root h by 2 is equal to root h minus a by a root g by 2. Let's call it t1. To empty completely, that is x is 0, we have root h minus a by a root g by 2 t. This is the total time. So t1 will be A by A root 2 by G root H minus root H by this T will be A by A root 2 by G root H. So for second half, what will be the time? For the second half, T2 will be T minus T1. Does it make sense? I'll find the time for the first half. I'll find the total time. Subtract them, I'll get T2. So T1 by T2 will be A by A root 2G. That thing will cancel. And you're left out with root H minus root H by 2 by root H minus this the root H by 2. That is root 2 minus 1. That's your answer. Previous page here. Let's check it out. Clear? Please check. Or if you want to use this formula only, can you tell me what will change in the formula? When you're going from H by 2 to 0, this H will be H by 2, na? You can do that. You can assume the water height is H by 2 initially. That means this height will be H by 2. This will be 0 and you'll get T2 from there also. That also works. Make sense? So whichever you are confident and whichever you are convenient, it is for you. I don't like that because I'm scared I will mess up. I'll put something goof up there. I like to take full time and subtract. Even though it is little lengthy, I'm more confident. Got this? That result is quite important. Do mug it up. Straightforward questions you get in the exam. They can ask you find the ratio of time taken to empty, find the ratio of first half and second half. Multiple things they can ask you. Next one. Arjun, clear? Neil, Udayan, Vidyut, got this? Maulika, clear, na? Do adjust your cam better. Maulika can't see you. Palaksh, clear? Adjust your cam. Ali, got this? Next one. We have a test tube here. Just filled with it's a liquid rho 2. This is rho 1. This is x1. So it's a test tube here and it is rotating with omega. This side is exposed. So atmosphere is P naught, atmosphere is P naught. This is x2. Neglect gravity. And this is a small hole. So liquid will start gushing out. Find velocity for flux. Know which formula to use? Remember this? This is better, no? This one and which other formula to use?
So sorry.
This one. So you have to combine both. Try. If you remember the derivation, this was the derivation. Na? Remember, what did you keep the limits as 0 to x? Here you'll keep the limits from x1 to x2, isn't it? The first liquid is from x1 to x2, second liquid is from 0 to x1. So here these limits will become x2 square minus x1 square. ऐसा हो जाएगा formula. Think for a minute, I'll show you. So you have to just remember the formula, pressure inside the just inside and pressure just outside, 2 delta P by rho. I'll give you more general results. Let's say we have rho 1 at distance x1. Then we have rho 2 at distance x2. At rho n at distance xn. So the pressure here at this point, right? If you take this as P naught, it will be P naught plus rho omega square x1 square minus 0 square. Remember the derivation? It was x dx ka thing. Second will be rho 2 omega square x2 square minus x1 square. So on till rho n xn square minus xn minus 1 whole square. That is the pressure inside. So delta P will be, remove that P naught there. So you can rho 1 x1 square minus 0 square, rho 2 x2 square minus x1 square, xn square minus xn minus 1 square, omega square. This is your delta P, and speed V will be root over 2 delta P by which rho? Rho is the density of the liquid which is coming out. So rho n. Got this? This is for n liquids. So in our case, there's only rho 1, rho 2, so ये terms नहीं आएगा. So in case you're confused, how did we get that? You need to go back to this guy, page 43, and look at the derivation. So here the limits will go from x1 to x2. So this will become rho omega square x2 square minus x1 square. That is for one liquid. Next liquid it will be from x2 to x3. Na? Next liquid will be x4 to x5 and so on. Because this rho is changing for different liquids, the limits will keep changing. So you can refer page 43. The limits will change in the integration. Clear with this, everyone? You can't cancel, right? Rho 1, rho 2, na? This is rho 1, rho 2, so terms don't get cancelled. Be careful. All clear with this? Got this? This way. So we used actually both of them, the 2 delta P by rho and that cylinder car rotation thing. Next one, anyone clear with this? All got this? Ali, clear na? Rehan, Swastika, got this? Udayan, Yasha, Partika, clear na? Next one. We have a bowl here with a small hole filled with liquid. It is observed when the liquid is leaking out, the liquid level is decreasing, or the liquid moves down with the speed of v meters per second. Basically, they will say the liquid level is decreasing at a constant rate. Now, generally, that is not true. Think about it. If you have a container and if you make a hole, tell me one thing: will the water level decrease fast initially or finally? Initially, will decrease fast now because there is more speed, more water will go out. As after some time, what will happen? The height of the liquid will decrease slower and slower and slower. That means the velocity of the water level is not constant. But this weird shaped bowl, right? It is happening that way. So find the equation of this bowl. This is an integer question. Question was like this: y is proportional to x power n. Find n. Got the question? So you have a bowl here. It's not a parabola. That much don't guess. Try. So in this bowl, when you have water and when it leaks from the bottom part, it is observed the liquid it will just go down at a constant rate, which is not true if you take a uniform container. Find the equation of the bowl. If it's an integer question, I'll ask you like this: y is equal to x power n, find n. Any answers? Find n. Just get me that. It's okay if you can't type the equation. If y is proportional to x power n, find n. There's no need to integrate. कुछ नहीं करना है. We'll get the answer in 3 steps. Now, before typing the answer, now you need to understand. Really, doesn't make any sense. If you have n is equal to 1, what kind of shape did you make? A straight line. See, So let the height of the liquid be y. Let this point be origin 0, 0. So this liquid here is at x, y. So velocity v will be root 2 gy. It depends only on the height. So in small time dt, a small amount of liquid will flow out, which will be dx. In time dt, sorry, this is dy. Let height decrease by dy. Right? So what is the volume that is outflowing? Volume outflow is area, which is pi x square into dy. But this is also equal to area of the hole into velocity v. So we have pi x square dy is equal to, you can a into v is root 2 gy.
Sir, into dt, no?
dt भी रहेगा ना, into dt. You can take a minus sign because it is decreasing. Then this will be pi x square minus dy by dt is a into root 2 gy. But dy by dt is nothing but minus u. Let's take the speed of the liquid to be u. I am already using v as a symbol, na? Minus u. Why minus u? Since y is decreasing. So this guy will be pi x square u, which is a constant. This is a into root 2 gy, square on both sides. Pi square, u square, x power 4, a square, 2g, y. So y is equal to pi square u square by 2g a square x power 4. Yeah, that is power 4, everyone. So this Bowl ka equation is y is equal to k into x power 4. K is that constant. So if you make a bowl like this, you can be sure the water level will go down at a constant rate. I think first time you saw a bowl which is not a parabola.
सर आपने u exactly क्या लिया? वो root 2 gy जो है.
Yeah, this is the velocity of the liquid coming out, na?
हाँ, तो वो u क्या है?
U is the speed of the liquid, na, which is dropping.
वही आपने v दिया था ना पहले.
हाँ, वो change कर लिया मैंने.
ओह अच्छा.
Because वो भी v, ये भी v, सब v ले रहा हूँ मैं.
ठीक है.
Got understood? That will
हाँ.
all become v, na, it will be messed up. So मैंने सिर्फ change कर लिया. I made it u. Just a symbol, nothing much. Is this clear, everyone? Whatever we did today, everything you should try them again, huh? Next one. Any doubts? Anyone not clear with this? Please ask me. Next one. We have an insulated container. Outside is vacuum. The entire inside is filled with an helium gas. Temperature is 1000 Kelvin. So here we have a small hole. So what will happen? The helium will start escaping. Find the speed of the gas initially. The moment you made the hole, find the speed of the gas. Find speed of the gas initially, meaning that is just after making the hole. neglect any flow within the container. Meaning, assuming this air is not moving, it is almost stationary. In reality, what will happen? The air will actually start flowing. We are ignoring that because the hole is small. Neglect flow within the container. That is, assume a helium in the container is at rest. Let's get this. This is a good one, right? You agree, right? You have a fully filled tank. At some pressure, you make a hole, the gas just rushes out. So find the speed of the gas at T0. How do we approach this? Think about it for a minute, then I'll give you a hint. You have to use this. Modified Bernoulli's equation. Because when the gas goes from container into vacuum, temperature क्या हो जाएगा? Once the gas goes into the vacuum, what will happen? It will just disperse, right? Temperature becomes 0 Kelvin. So what happened to all that internal energy? The outside is completely vacuum. So if you send little gas outside, it will just spread out. Molecules will go very far. So there'll be no temperature, no pressure, nothing. So outside the pressure is 0, outside the temperature is 0. We have to apply the modified Bernoulli's equation. And how did you have to apply modified Bernoulli's equation? Till now, in any equation, did I give you temperature? That should have been the biggest clue. Whenever the liquids are flowing and you're talking about temperatures, he's expecting you to use modified Bernoulli. Try, give 2 minutes. show you. Root 5r by 4. कितना टेम्परेचर आ गया आंसर तुझे? नारायण, देन टेम्परेचर का मतलब क्या हो गया? You should think like that, ना? See, let's apply Bernoulli equation between 0.1 and 0.2. Same height basically. So V1 plus half rho V1 square rho GH1 plus potential energy U1 by volume V1 root 1250 R. Okay, let's see. Oh, let me just write like this thing. So P plus rho GH plus half rho V square plus potential energy by volume is constant. So on the left hand side, pressure is P, height is 0, velocity is 0 because you neglected the flow. The internal energy is F by 2 nRT by volume is V. RA.
Height 0.
Come again?
Height 0 अपने
1 and 2 same level पे लिया ना God. Same. What is height here? H is the reference line, na? You can choose anything you want.
I see.
1 and 2 same height हो जाएगा. Outside pressure is 0, height 0. This will be half rho V square and internal energy is 0. ये terms clear है? Cross multiply. This will be P into volume. I'm writing the full thing because you'll get confused with this. F by 2 nRT is equal to half rho V square into volume. Just let's keep the volume here only. What is PV equal to? nRT. So nRT is 1 plus F by 2 by volume. Half rho V square. Rho into V is actually mass. I can send it. That's it actually. That will be half into mass into velocity square. Then if I shift it this side, nRT, N is number of moles. What is mass by number of moles? Molecular weight, na? So RT, F is 3. So 5 by 2 mass by number of moles is half V square. So V will be root 5 RT by molecular weight. 5 R temperature is 1000 and molecular weight of helium is 4 gram. That is 4 into 10 power minus 3 kg per mole. 1000 comes out. 1000 root 5 R by 4. Clear? Remember, molecular should be always in kgs. What you have is 4 gram per mole. So 4 kg में लिखना पड़ेगा. That's how you do this thing. Thermodynamics, KTG, fluid mechanics. Modified Bernoulli's equation. So the main idea here is the temperature changes. Please look at the steps. Any doubts on this? Clear? Next one. We have a container here with a small hole. Only reason I'm giving you small hole every time is the formula is root 2g, it will be easy. Whose area is small a? This area is a. Initially tank is empty. Now here on top you have a tap. So this tap is releasing water at a rate of Q meter cube per second. So what will happen? As the water is falling here, the water will start leaking also. You're getting it. Initially tank is empty. As the water falls initially, because the height is less water will go out, but more water is coming in, the height will increase. As the height increases, more and more water will go out. So height of the liquid will not keep on increasing forever. It will start stabilizing. Find the height of the liquid as function of time t. I can ask you plot the height of the liquid as function of time t. The graph would be more fun. Can you guess the graph? Without solving, can you tell me how will the graph approximately should look like? Meaning, if this question asks you which of the following is the graph for height as function of time t, height versus time, what will you look in the options? Again, I tell you every time, whenever you have to guess, you can't guess the right option. If you can guess, you'll mark it. Na? When you're guessing, you're always finding the wrong options. So can you tell me what will you look in the options to see whether something is right or wrong? Anything.
Temperatures at higher times will become like the same height.
Which one?
Like at higher time, the height will become like almost a straight line.
Okay, that is one. What else?
It will start off like looking like root x graph, and then it will be like asymptote, a horizontal asymptote.
The graph starts from where?
Origin.
Origin start on initially height. And like this, no?
Yes. Yes.
It should look like this. Making sense? You can't have a graph like this. Why the graph will look like this? Think about it. Once you reach a certain height, the water is going out so fast, the inflow is equal to outflow. The height will become constant. You can't get more height than that. Now find the height as function of time t. This question is a better variation of this one. Ye second question ka better one this is. In this already liquid is there and you're flowing out. Here the liquid is coming in and you're flowing out. Get this. Just get me the equation. We'll not integrate it. You will learn in max when you can do this. Just get me the mathematical form and leave it, integral form. क्या करना था? I told you multiple times. How do you start the problem? Can someone tell me how do you start the problem?
Take the intermediate stage.
Take the intermediate stage. After time t, let the height be x. In time dt, let the water fall inside q dt. In time dt, let the water flow outside area of the hole into velocity of the liquid into time dt, isn't it? The liquid increase by dx. Matlab, you always start like this. It is not only about this chapter. Let it be thermodynamics, let it be current electricity, magnetism. Any chapter you see, something is changing. This is how you start. Start on the intermediate stage. Now see, these are the things. This is not subject. What I told you right now is not subject. These are the techniques you will learn when you solve enough level of problems. You will start understanding. अरे problem आया ना, पहले मैं start कर लेता हूँ ऐसा. Exam में ना, the main reason that you keep on staring like मैं क्या करूँ. If you start this, it goes ahead. BH by root h इतना अच्छा नहीं आएगा रे ऐसा. Q कहाँ पे है तेरा? That Q is only not there. You killed the Q. You're chewing gum क्या? That's why you're not able to figure it out. Throw the gum away. You will focus better. Let's say. Let the height be x. So in time dt, let the liquid coming is q into dt. This is the inflow. This is area into root 2 gx into dt. This is your outflow. And let the height increase by dx. That is your change. So inflow is q into dt. Outflow is a into root 2 gx dt. So where did the balance go? That went to increase the water level, na, adx. Make sense? I got something. Something went away. Balance gaya kahan pe? Balance is used to increase the height by dx. So dx by q minus a root 2 gx. This is a integration 0 to x, 0 to t. Leave it there. You can solve this. This is nothing but dx by something like a plus b root x integral. It's not tough. We can solve integration by substitution. You can say put q minus a into root 2 gx is equal to z, and then from there you can start. Let it be. Maximum when you learn, you will see this is easy, nothing but it is. But got till here? The most important thing is understanding this inflow, outflow, the balance is this bus. That is physics. Then max part is fine. That you can handle it. Clear with this? Next one. Let's say we have containers. Right? Thin pipe. So these are two containers with a thin pipe. Area is it is a thin pipe. In the middle there is a tap. On this side the liquid ka height is 2h. On this side the height of the liquid is h. Now if I open that up, what will happen? Liquid will flow from left to right. Getting it? I can ask you find the time when the heights become equal. Or even better, I can ask you find the height of the liquid in the containers as function of time t. Let me ask you this thing. Find the time when the height becomes same. after tap is opened. Question is making sense? If you have 2H and H, the liquid will keep flowing. If you ask me, na, better question would be this H1, H2, and I'll ask you find the height of the containers as function of time. Yeah, ठीक है. Meaning, if you do this, the idea is the same. The variables will be more complex first. You're getting the reason for thin pipe, right? So the flow will be, it will not rush and go. हाँ, containers are identical. फर्क पड़ेगा क्या? हाँ, पड़ेगा. Actually, वो भी बहुत अच्छा question है. What you asked, Ajit. You can make this H1, you can make this A1, you can make this A2, you can make H2. It will be pretty deadly. But okay, let's not make it deadly now. We'll kill you later. For now, make it equal. Right now, killing is happening for your seniors, not you. First, we have to make you strong, and then slaughter you. Hey, isn't that how you teach someone? First, you teach them, make them feel like, हाँ मुझे सब आता है, and then you smash them. Then your subject will improve. Root h root 2 minus negative आ गया रहने का इधर हाँ root 2 minus root 3 मतलब this container will become equal in the past. You have invented time travel. बस ये बच गया था. Till now you guys were experts in creating perpetual engines. Free energy था. Now you have time travel machine also. You can go into past. How do we start? Same thing. Let the height be h1. Let the height be h2. Then I'll give you a hint. Then what is the pressure here? Root 2 g h1. What is the pressure here? Root 2 g h2. So what is the difference in pressure? Root 2 g h1 minus root 2 h2 by rho, na? That is the pressure difference. So what is the velocity flow? Root over 2 delta p by rho. Making sense? So from there we'll get it. Let's see. I don't know whether we can solve this or not integration. Maybe I should have made one side empty, I guess. No, difference nahi badega. 3 root 2 h cube d. I don't know the answer. This is the first time I'm doing this. No, you can do this actually. Relation आ जाएगा h1 h2 का बीच में. See. Let this side be h1. Let this side be h2. Volume is conserved. No matter how much the liquid changes, volume is constant. So A into 2H plus A into H should be equal to A into H1 plus H2. So H1 plus H2 should be always equal to 3H. This relation is always maintained, isn't it? At this point, the pressure, let it be P1 is P0 plus rho G H1. At this point, the pressure P2 is P0 plus rho G H2. That means the liquid will enter like this and will come out from here with speed V. Na? The velocity is liquid is flowing out with speed V. So V is equal to root over 2 times delta P by rho. This is the velocity of the fluid leaving and entering through the pipe. Velocity of the fluid through the pipe. You can use this formula only if the pipe is thin. That is the reason I made the pipe thin. Through pipe. So this guy would be V is equal to root over. Rho will cancel 2g h1 minus h2. So in time dt, let this height decrease by dh1. So volume outflow so volume decrease will be minus A into dH1. That should be equal to area of the hole into V into dt. That is minus A dH1. A velocity is root 2g h1 minus h2 into dt. h1, h2 both are variables. Replace h2 here. h2 is 3h minus h1. So minus A by A root 2g dh1 by root over h1 minus 3h plus h1. So 2h1 minus 3h is equal to dt. Integrate on both sides. This will go from 0 to t. This will go from initial height is 2h to some height h1. Finally, what will be the heights of both of them? 3h by 2, na? If you want to find the time when the equations will become equal, the height becomes 3h by 2. इसका इंटीग्रेट करते हैं एक्चुअली. So minus A by A, I'll turn the page. Root 2g integral dh1 by root over 2h1 minus 3h is equal to integral dt. This goes from 2h to h1. So put 2h1 minus 3h is equal to z. So 2dh1 is equal to dz. These people are shouting, right? dz by 2 root z, and top of it they're singing some weird language songs. That is a problem. I'm not understanding also. I think it's Marathi songs. So the 2 will come out minus A by 2 root 2
तो वो 3h कहाँ से आया?
2. अरे
वो 3h कहाँ से?
ये है ना, h2 को रिप्लेस कर लिया मैंने.
ओह अच्छा okay.
दोनों वेरिएबल्स है ना, ये h2 को ये पे डाल दिया. इसका इंटीग्रल क्या होगा? dz by, तो that would be 1 by 2 z पर minus of ना 2 root z. Limits will go from 2h2 to z. This side is t. Limits अभी भी है. 2 will cancel. Minus A by 2 z. Z is what? 2h1 minus 3h. Now put the limits. 2h to h1 is equal to t. Solve कर लेना, आ जाएगा answer. It's only max from here. But main thing is this, take the steps. If you got to this integration, you are done with the problem. You getting what we did? On both the sides, when the liquid is going, the pressure difference will keep changing. Because the pressure difference is changing, the velocity will change. And because of which the flow rate is changing. But इस बार दोनों साइड चेंज हो रहा है. One side is increasing and one side is decreasing. This question would be more deadly if I take this as A1 and A2. Meaning logic to same concept, but mathematically it will become more complex with too many variables. Clear with this? You're getting how we can play with this velocity of flux? So in fluid dynamics, if you see, right, these are like, this velocity of flux is the main thing. After this, we have another 3 things, but it's all theoretical. So let's see them. Clear? Next one. Now, in the Bernoulli's equation, P plus rho g h plus half rho v square is constant. So if you consider 2 points at same height, then H will be constant. You get P plus half rho V square is equal to constant. You'll see something interesting there. This implies if V increases, P decreases. Now don't get confused here. What this means is, there, have a look at this. ये just integration है, कुछ है ही नहीं उसमें.
सर आपने H1 H2 फाइनल हाइट्स लिए थे ना?
नहीं, it's function of time t ना. H1 H2 are the heights in the intermediate stage. Final heights तो 3h by 2 हो जाएगा ना रे.
हाँ अच्छा, इंटरमीडिएट.
Final height तो 3h by 2 3h by 2 हो जाएगा. उसमें इतना क्या है, equal heights हो जाएगा. If V increases, P decreases. Now let's try to understand what is this meaning. Now see, when you have a container, if you have a slow moving fluid, tell me one thing. Remember in the beginning I told you, why do you get pressure? The reason you get pressure on the container is because the molecule, while it is going, it is colliding with the wall, isn't it? The pressure is due to the molecular collisions. Now, if you have a fast moving fluid, the liquid is flowing pretty fast. Now, what would happen? You're getting it? The number of collisions will decrease, isn't it? You're having less time for the molecules to collide, the number of collisions will decrease. So this is the thing. So you're not giving enough time for the molecules to interact with the walls or, have enough collisions. Therefore, pressure drops. Now, don't get confused this with the water jet. Water jet we wrote now, force is rho AV square. Sir, if speed is more, force is more, you're forgetting something there. In the water jet comes and hits the wall and stops. यहाँ पे no one is stopping. The liquid is simply flowing. You're getting it? This is the pressure in the surrounding region. This is not the pressure when you hit the wall. I hope you're getting the difference. So whenever the speed increases, the pressure in the surrounding decreases. You see this phenomena at multiple places. Turning the page. So exam there is a question like this. This is point A, this is point B. At which point is the pressure more?
A.
Whoever has less velocity will have more pressure. So here if you see VA is less than VB, therefore PA is greater than PB. But you know what generally people think? Sir, यहाँ पे liquid बहुत fast जाएगा, it's a thin pipe, तो pressure बहुत ज़्यादा हो जाएगा. You're forgetting it. If the liquid hits the wall and stops, it will get more pressure. But it is not stopping, it is flowing. The general tendency that we think is that only. We think because there's a blockage, the pressure will rise. Clear with this? So, if you take an example, you must have seen this in your room only. If you have a wall, and let's say if you have a fan or something, and when the wind is blowing here, tell me one thing, if you have a calendar which is there, if the wind is blowing downward, shouldn't the calendar stick to the wall then? But what do you observe? The calendar flies. Reason? When this is a calendar, and when the wind is blowing here fast, so here V is more, pressure is less. Because the pressure is less, this pressure will push it up. Making sense? So let's say this is P1, this is P2. P1 is greater than P2. Not only this thing, when you see especially this F1 racing cars and everything, right? Tell me one thing, how do you design the car? I know that looks weird, but yeah, you can draw better. So we have a car like this. So this is V1 and this is V2. Which one should be greater? Think about it. You want the car to fly or you want the car to be on the ground?
V2
You want to be a car on the
should-
ground. So this is P1, this is P2, right? You want P1 greater than P2, na? So that this force P1 is pushing it down and this force P2 is pushing it up. P1 greater than P2, therefore V1 must be less than V2, isn't it? So the car ka front part should be designed in such a way the wind is blowing faster at the bottom and slower on the top. Making sense? Same way, if you take a blocked artery, what is a heart attack? Heart attack is nothing but the blood flow stops to the pulmonary artery or some artery which supplies blood to the heart.
Of the aorta.
Yeah, so basically उसका कुछ नाम है, okay, जो भी है, some artery will get blocked. Now generally this is what people think. You know, there is a blockage here. So, you know, the liquid, the blood or whatever is flowing will be what? It will flow faster like this, right? So here the area of cross section is decreased. So speed is more. So you know what people think, pressure बहुत ज़्यादा बढ़ जाएगा. But actually think the other way around. So here, if you look at this point here, P1 and P2, at P2 pressure decreases. P2 decreases. And because of this, what will happen, you know? Your blood pressure, which is there, that is pushing outside, which is P0 into area. This side is pushing P0 into area. Whereas this pressure is only P2. And here, P2, P0 is greater than P2. What will happen? Your artery will get pinched. You're getting it? It will actually get crushed. And the blood flow completely stops. You're getting this? That little blood which is flowing, that also will completely stop once the pressure difference becomes large enough. Your artery cannot withstand that compressional force. That is the reason after clearing the artery, what they do, they keep a stent inside. अब logically सोचो ना, if the pressure becomes more and the artery bursts, shouldn't you keep the support outside the artery? But when they introduce the stent, they put the stent inside so that the artery won't collapse inside. Making sense? Same thing, ever seen Antarctica Hills? If you see an Antarctica nest or, you know, especially the termites, they build, you know, these Antarctica Hills. Why? You get a better view. Top view, अच्छा लगता है building को ऊपर से, right? Not exactly. If you go and break that, if you observe, right, you'll not find any ants in that. The ant hill actually, right, is called a wind tower. This is a concept to cool, you know, this thing. What happens is, if you see an Antarctica hill, it is pretty intricate. You know, the nest is something totally sealed and, you know, closed kind of thing. Something of this sort. So it's totally like this. So do you ever see when you go to a tall building, what happens? The wind flows faster. Because of which what will happen here? So at this point P1, at here the pressure is P0. P0 is greater than P1. So the Antarctica, there is an opening. So the air will go into this and you get a ventilation. Because think about it, ants also breathe out carbon dioxide, no? And carbon dioxide is heavier than air. The entire nest will get filled with carbon dioxide. They'll suffocate and die. So you need to have a ventilation system. If you go and break that hill, immediately they'll come and construct it. That is actually called a wind tower. If you see these old buildings, especially, you must have seen these kind of houses. They have a courtyard like this in the middle of the house. 4 doors and the center mein aisa hota tha beech mein. So previously there were no ACs and all. So the central tower, they built this thing like 4 to 5 floors higher. Getting it? And this is open, okay? The moment you open the door, the air rushes in from the sides. You get air continuously into the house. This is how you can cool down the entire house without any ventilation. You'll observe this in some buildings in Mumbai also. In Molena, there is this one area here. This person built 8 towers, all close, almost pretty close to each other. ये कैसा हो गया ना? It almost became like a wind tower. If you go and stand below the tower, you'll find wind blowing continuously. So it's a concept that way. The same thing, you can also take a football. I'm sure you must have seen banana shot, football fans here. So if you take a football here, and let's say if it is going with V and rotating with omega, at this point here, the velocity will be V plus R omega. At this point, it is V minus R omega. So this is P1 and this is P2, and P1 is greater than P2. So this ball will get pushed up like this. This you must have done when you kick the football. You must have seen it goes above the goalpost sometimes. This thing goes up. This is called Magnus effect. Clear? Now, the question they can ask you in the exam, right, is an aeroplane wing, same concept. So in an aeroplane wing, the wing is designed in such a way so this is V1, this is V2, this is P2, this is P1. Height is almost negligible. You can apply Bernoulli's equation. P1 plus half rho V1 square is P2 plus half rho V2 square. So P2 minus P1 into area of the wing is half rho. This is the density of air into V1 square minus V2 square into area of the wing. This is the thrust force on the wing. Density of air into V1 square minus V2 square into area. This is the force on an aeroplane wing. This is a question in the exam directly. They'll give you the values and they'll ask you how much force is acting on the aeroplane. If there are two wings, A is the total area, okay? If you want the total force, it is the total area. If you want a force on one wing, then area of one wing. Standard result. So this is the reason why planes fly, you can say. Normally, you must have noticed that when the planes take off, they reach speeds of almost 180 to 200 kilometers per hour. So that differential in velocities will create this pressure difference, and that will take you a lift off. Clear? These are all just diagrams, right? I didn't even draw beautiful diagrams. What is there to see these things? I don't draw any bullshit there. Yeah. I'm not even using my desktop today. It is all weird. Let's see how it took off. There. See how it looks. So you have to design them properly. These things, right? At that speed, they become planes literally. And मजा आ रहा है ना कार से गाड़ी. That is one. And then look at this thing. This thing starting only you can see this. See how that ball curves?
So you want to learn how to curve.
Did you see that? I'm lagging, I guess. The ball literally curves, like, you hit it to the right and it takes a turn. There's a guy called Robert Carlos. You can search in YouTube, you'll find a lot of, it's called a banana shot because it takes a curve like this thing.
So you want to
This guy
learn
teaches
how to curve the
how to
ball.
kick
Well,
the
in this
ball.
episode, I'm going to give you a step-by-step tutorial on how to hit those bending
Look at this thing. This is a good one.
Recently, some friends of mine went to the Gordon Dam in Tasmania, which is 126.5 meters or 415 feet high. Then they dropped a basketball over the edge.
So these guys just dropped a ball. And you'll observe it
You
just
can
falls
see
almost
that the
straight.
basketball gets pushed around a bit by the breeze, but it lands basically right below where it was dropped. Now watch what happens when they drop
Now they're giving a spin. Now when you give a spin, what will happen? There's a differential pressure and the ball gets pushed up a bit. Right?
another basketball, but this time with a bit of backspin. Whoa, look at that go!
It's incredible.
It went pretty far. Did you see how far it went horizontally? That's the Magnus effect which I was talking about.
This is Brett who just threw it. I literally just dropped it with a bit of spin,
Just
like I
started
didn't
gliding.
even throw it, and it just took off. Like we had no idea that was going to do that.
And this
I'll send you that video. Check it out. I think I'm lagging a bit. There's one more I wanted to show you. Yeah. This is a little evil thing, but it is for the greater good of science. We'll sacrifice some ants. So someone found a nice anthill. Looking cute. That is molten aluminium. We poured into this cute nest. Kept on pouring and pouring. The poor thing gone. And then he started cleaning and removing the mud. Then he washed it. That's how the final piece will look like. You polished a bit here and there, clean it up. It's almost 10 kgs in weight. Nice, huh? It is a good art piece by killing some 10-15,000 ants. Recently, these people in Africa, they found a big ant colony which is 20 years old. These people poured 11 to 12 tons of concrete cement into it. And they found, a 2-story structure inside. And estimated they killed 700 million ants. That is 70 crore ants. So, yeah. Clear with this thing, Magnus effect? The next thing. Yeah, this is the second concept, it's aeroplane wing. The third one is a venturi meter. Again, these are theory plus concept both. In venturi meter, we have two cases, an open venturi meter and a closed one. You see in your house, right? You get your gas pipeline, right? How does that meter know how much gas are you using per second? Someone has to measure the flow rate, isn't it? So inside that gas meter, we have some kind of device which measures actually how much gas is flowing per second. Now, this is an open type. We don't use this. There is a second version of this. That is the thing which we use. So let's say the height is like this. Let the velocity be V1, pressure P1, V2, pressure P2, area A1, area A2. Let this height be H1, let this height be H2. So difference in height is H1 minus H2. So the device can measure the difference in height. Now applying first thing equation of continuity. So don't remember the result, you should know how to derive this. The result is little, yeah, you can derive this. It's a little big. A1 V1 is equal to A2 V2. P1 plus height is same. Half rho V1 square is P2 plus half rho V2 square. And P1 is also P0 plus rho G H1. P2 is P0 plus rho G H2. So these are the three equations, three unknowns. Subtract them. We get P1 minus P2 is rho G delta H. So from equation 2, we can clearly see here P1 minus P2 is half rho V2 square minus V1 square. This is rho G delta H half rho. You can find, let's say, V2 square minus A2 square V2 square by A1 square. So we get V1 is equal to root over 2G delta H by, this thing looks like velocity of flux only, 1 minus A2 square by A1 square. There I got the velocity. The volume flow per second is A2 into V2. So the machine can find delta H. We already know the values of A2 and A1, isn't it? From there I can find the how much volume is flowing per second. So venturimeter is actually used to find the flow rate. So we have a device or a sensor which can find the delta H ka height. You already know the remaining values, 2G 1 minus A2 square by A1 square ka values. By putting those inputs, you will get that constant. And that sensor will measure the delta H and multiply and will tell you how much gas is flowing every second. And that is how your meter will actually charge you. That is how the meter knows how much you are consuming. Clear? So next time when you see that gas meter, it is working based on a venturi meter. But this is an open one. I'll show you a closed one, what it actually uses. You don't want to have an open one like this. Gas will leak and there will be a blast. Not a good idea. Clear? Next one. Any doubts on this? What it did? When it is all simple. It is just one Bernoulli equation, one equation of continuity, and you're done. Alternate. This is the one which we use most. We connect the venturi meter to a manometer is connected. This is how the design works. So here we have a liquid flowing. So inside the manometer, you have mercury. H2, H1, and this total height is H. So this is the thing there. If you look at the difference here, again, this is your delta H, this is your X. So the sensors can measure the delta H. So here the velocity is V1, pressure is P1, area is A1, V2, P2, A2. The first thing, equation of content. Again, remember what is your purpose? Your purpose is to find the this thing, what the V2 or V1, anyone. A1, V1 is A2, V2. And then Bernoulli's equation P1, half rho V1 square is half rho 2 V2 plus half rho V2 square. And if you look at the pressure difference, let's call this point A and let's call this point B, because both are at the same height in the same liquid, PA is equal to PB. You get P1 plus rho liquid G X plus delta H plus rho mercury H1 should be equal to P2 plus rho liquid G X plus rho mercury GH2. Simplify this a bit. P1 minus P2, the rho LGX will cancel. We get rho mercury minus rho liquid G H2 minus H1 delta H. That's your pressure difference. And this is nothing but half rho V2 square minus V1 square is rho mercury minus rho liquid G delta H. Oh yeah, same thing, substitute that thing. From here you'll get V2 ka value. And the volume per second is A2 V2. You know what gas you're sending in the pipe, you know the mercury density, you know delta H from the sensors, you know everything. This is what we use in the venturimeters to measure the gas flow. So if the gas is flowing pretty fast, the height will change. Accordingly, you will get the velocities. If the gas is stagnant, what will happen? H1 will be equal to H2. The flow has stopped. The meter will stop working. Clear with this, everyone? Venturimeter. This is your third case. Clear? It's not difficult to derive. Remember Bernoulli's equation of continuity, and P plus rho J is constant. That's it. And the last thing in this is siphon. Siphon, you must have seen this. If you put a pipe in a water tub or something, and if you suck the air out of it, the water will start flowing automatically. Ever did that? People generally use that to steal petrol from bunks and everything. You know, ever stole petrol? No. If you ever stealen petrol, you'll understand. Or if you have taken petrol from your friend ka bike or something. So siphon. Simple one is this, you know, you went to the barber shop, right? They use that thing to spray. That's actually kind of a siphon only. You're making a vacuum inside, and when you press, the water rushes out. But let's see what is the concept here. It's an easy one. I got disconnected with. This place has issues, but chalo, at least till now we didn't have a problem. By tomorrow the luggage will be arranged, so it should be fine. have to go. My wife will be angry. Oh, your students are more important than arranging and helping me out. Then I will tell you it's kids ka career. Something like this. I'll say 2-3 dialogues like movie ka things. So normal only. So this is height h1. This is height h2. This is height h3. So here, how will the liquid flow? Liquid will flow from here. We'll go through the siphon. And then it comes out. So if you consider this as 0.1 on the surface and this is 0.2, and let's consider this as 0.3. Your h1 is the height of the liquid above the ground. h2 is the height of the opening where the liquid comes out. h3 is the max height of the siphon. So first thing, let's apply Bernoulli between 1 and 2. So if you see at P1, it's an exposed to atmosphere, pressure is P0 plus rho GH plus half rho V1 square. We neglect this. It's a big area. The pipe is small. P here also P0 rho GH2 plus half rho V2 square. Straightforward. So V2 will be equal to root over 2G H1 minus H2. Meaning the liquid will keep flowing till the height becomes same. Once the height is less than this, the liquid will stop flowing. Kind of makes sense. The reason why the liquid is coming out is because of what? Liquid is flowing from higher potential energy to lower potential energy. The reason why you need to pull the air out is this thing. See, remember in chemistry you studied this thing. Even though the products are more stable than reactants, you have to provide the activation energy. Same way, you need to create a vacuum here for the water to get sucked in till here. After that, automatically it will start flowing. But there is one more catch on this. If you apply Bernoulli's between, let's say 1 and 3, or 2 and 3, we have pressure P0 plus rho GH2 plus half rho V square. This is P3 plus rho GH3. Area of the pipe is same, so half rho V square. You end up with P3 is equal to P0 minus rho G H3 minus H2. But I know pressure should be always greater than equal to 0. V8 H3 minus H2 should be greater than equal to P0 by rho G. So if you're taking water here, this is 10 power 5 by 10 power 3 into 10, approximately 10 meters. What is the meaning of this? If you make the height of the siphon more than 10 meters, siphon will stop working. Simple thing. Do you remember in barometer we did this thing? If you make a vacuum, what is the height of the water level? 10 meters, isn't it? Now, let's say someone makes a siphon like this, which is 12 meters. And now you tell me, even if you create a vacuum here, what is the height of the water level it will reach? It can go only up to 10 meters, no? So water won't even reach the topmost point, right? Siphon will not work only. Are you getting the catch? So for a siphon to work, there should be two conditions. One, H1 should be greater than H2. The difference in height can't be more than 10 meters. Fair enough? That is for water. Depending on the liquid, the height can be different. So in fluid dynamics, right, primarily first thing we have the streamline flow, equation of the streamline. Then we have equation of continuity, and then we have Bernoulli's theorem. Bernoulli's theorem, we have primarily there are four concepts. One is the velocity of efflux. That is the most important one. We did a lot of models. And then we have aeroplane wing, that is easy. Then venturimeter is easy, and siphon. The last three are actually kind of conceptual. Clear? With that, we are done with fluid statics and dynamics. So next class, when we catch up, we can start off with viscosity. Now, did they finish off viscosity there for you guys? No? They didn't start. They started SHM?
Matlab they did properties of
One second.
Properties of matter.
I can't hear actually. Someone's saying something. Huh? Did they start viscosity?
No,
No.
they didn't teach.
But it's not fluid dynamics that done, right?
Yeah, till where you've done this.
Okay, then let's start with SHM in the next class then. We'll start
Okay.
with oscillations. After that, we'll go to viscosity again. Okay, with that, we'll wrap up for the day. Today, I won't be able to take much doubts, but any doubts in today's class, you can ask, right? But any other doubts, let me see it in the next time. My back is already
That's
paining. I
okay.
can't sit here. Chalo, but